Hello everyone, welcome to IG Bits. We train, you learn. How are you guys doing? How's your preparation going? Good to hear. Let's utilize this opportunity to gain max knowledge, build the confidence. We are approaching very near to our competitive exams. All the best to you guys for your preparation. So, we shall continue some of the problems in motion in a straight line. Let's get started. We created a YouTube channel. Visitors at our YouTube channel @IGBits. Feel free to subscribe the channel. We started uploading all our sessions in YouTube. You can utilize this opportunity and build your competency. All right. Yeah. Thank you. Let's look at formulae for uniform acceleration motion that we have seen in last class. We talk about a straight line motion and vertical line motion, right? In a straight line, we have four formulas: v is equal to u plus at, s is equal to ut plus half at square, v square minus u square equal to 2as, s and equal u plus half 2n minus 1, isn't it? For vertical line, we have two cases: upward direction and downward direction. In case of upward direction, acceleration a equal to acceleration due to gravity g, a equal to g, positive value. So if you can replace a with g, then you have the all formulas as is, right? V is equal to u plus gt, s is equal to ut plus half gt square, v square minus u square equal to gs. So whereas downward direction, vertical motion in downward direction, in this case acceleration a is become like a minus g, minus acceleration due to gravity. Then all the formulas becomes v is equal to u minus gt, s is equal to ut minus half gt square, v square minus u square is equal to minus 2gs. Okay, if you remember, I think you will be able to actually attempt some of the problems. Okay? Solving is much easier for us. Okay, let's look at this problem. I'm reading out. A thief is running away on a straight road on a car moving with a speed 9 meters per second. A policeman chases him on a motorcycle moving at a speed of 10 meters per second. If the instantaneous separation of car from the motorcycle is 150 meters, how long will it take for the policeman to catch the thief? Who is going to solve this problem? Let's try out. If you look at, there is a two people, right? Thief and the policeman. That is a hint. Thief is having a car moving with a speed 9 meters per second. So velocity of thief is given. How much? 9 meters per second. Now, policeman who chases him on a motorcycle moving at a speed of 10 meters per second. So let's see VP. Velocity of the policeman is 10 meters per second. So one thing is interesting. Since the policeman's velocity is little higher than the thief, I'm sure I think the policeman is going to catch him, right? The another interesting point that we have to make out is there are two velocities are given. That means this probably a relative velocity story. You have to look at now, right? So I have thief, right? So it's going on this 9 meters per second, and then have the fellow going and 10 meters per second. So what is the distance they were talking about? The instance distance between them is 150 meters. Something like that, you can think. So what is the relative velocity? So we are talking about the velocity of the police with respect to the thief, right? VPT means VP minus VT. Velocity of the police with respect to velocity of thief. How much? 10 minus 9. This is like 1 meters per second. Units are same. So distance is 150. Now what is talking about? How long it takes for a policeman to catch the thief. So what we have to do, time t equal distance by velocity. So distance 150 and then velocity 1. This is nothing but 150 seconds. So policeman can catch the thief in 150 seconds. That's the solution. Alright. See this one. I'm reading out. A car moving with speed of 50 km per hour. 50 km per hour. So that means like we have to convert into meters per second. Can be stopped by brakes after at least 6 meters. If the same car is moving at speed of 100 km per hour, then what is the minimum stopping distance in meters? I think if you look at this problem, we have two scenarios are given. One scenario probably we can think of extracting unknown value which we can use in the second case 1 and case 2. That is how I am reading. Let's see like what is it case 1. What is talking about case 1? Case 1. Case 1 we talk about velocity is given, speed basically, right? So speed u equal to 50 kilometer per hour. That means 50 into what is the conversion? 5 by 18, right? Meters per second. This is what conversion. What is telling about? He applied a brakes. So in 6 meters the car will stop. That means like final velocity would be 0. S would be 6 meters. That's what given. Acceleration. Maybe let's assume acceleration A because we don't know anything. So by looking at this, probably we are looking at A needed for us to use the second case. Let's see what is there in the second case 2. If the same car is moving at a speed 100 km per hour, so u equal to 100 km per hour. This means 100 into 5 by 18 meter per second, isn't it? Good. So here also same case, v equal 0. So a is nothing but a. What we need to calculate s value. So what would be the formula that I can use? So for a given inputs, most likely our formula would be v square minus u square is equal to 2as. This is sufficient. Let's apply. In case 1, v equal 0 and then use 50 into 5 by 18 whole square equals 2a into 6. Let's say formula 1, equation 1. Now see this similarly, 0 square minus 100 into 5 by 18 whole square equal to 2as. This is equation 2. So let's divide now equation 2 by 1. How do you do this? 100 in 5 by 18 whole square 2as divided by 50 into 5 by 18 whole square. How much this is? 12a. Let's say cut this 2 and then probably 2. So what happens? We get 4 equal to s by 6 because 2 1 ja 2 6 ja, isn't it? So this implied s equal to 4 into 6, which is 24 meters. Are you clear? Well done. If a body starts at a rest and moves with a uniform acceleration, then the ratio of distance covered in 1 second, 2 second, 3 second would be. Okay, I will pause per minute. I think you can try out and then let me know. What is given? A body starts at rest. So u equal to 0 is what given. Alright. So what would be the formula is the time is given, right? T1, T2, T3 are given like a 1, 2, 3. So if you look at S is equal to ut plus half at square. So what's happening? This is gone and then S is proportional to T square, right? So S1 is to S2 to S3 equal to T1 square is to T2 square is to T3 square. Right. So the answer would be S1 is to S2 is to S3 would be 1 square, 2 square, 3 square. So 1, 4, 9. So answer B is correct. See how simple it is. If you understand the concept, what is given, which formula that you have to use, then our solution would be easy. Huh? Is it a nice problem? Good. Let's move on to the next problem. Let me read out. Two trains of length 100 meters, 125 meters are moving in mutual opposite direction along parallels. Meet each other, each with a speed 10 meters per second. If the accelerations are 0.3 meters per second and 0.2 meters per second, respectively, then the time they take to pass each other will be. So what is given? The length of the trains are given. Moving opposite direction along the parallel line. Sounds to me this is a relative application, relative speed story. And speed is also given 10 meters per second. Each train is moving in opposite direction. Their accelerations are also given, right? So as per the relative motion, if the both are opposite direction, what we have to do? We have to add them. Is it? So total length, if you want, let's say the relative velocity with one with respect to other. What would be the relative velocity? So let's see. Relative velocity one with respect to other. How much? 10 minus of minus 10. That means like 10 plus 10, 20 meters per second. Okay. And the relative acceleration also is given. Relative acceleration. How much? 0.3 plus 0.2. It is nothing but 0.5 meters per second square. This is also given. Now, what is needed? Length of the train is given. So, S is given. S1 plus S2, which is 100 plus 125. So, 225 meters, which is also given. So, think of a formula. What we need is like T. So, what should be the formula? S is equal to ut plus half at square. This is needed. Alright. So what is S value? 225. And what is U value? 20. So you would say 20 T plus F. Acceleration A is 0.5 into T square. So how to make it simplified? 0.5 T square minus 40 T how do you say 450 equal to 0 plus probably this one. So use a quadratic equation. If you solve this, you will be getting T value. Alright. So you can use factors methods, or you can also use minus p plus or minus root over b square minus 4ac by 2a. Right? We can use both ways. I hope that answer approximately 10. You can check out. Okay, so you can simplify it. Average speed. The average speed of a particle for a given interval of time is defined as a ratio of total distance traveled to time taken, total time taken. So average speed is nothing but total distance traveled by total time taken. So what you have to do now, look at the example A to B, we have a distance x, B to C, we have a distance x, the distance are same, and then T1 and T2 are the variant. Then we have velocity V1, V2. This is also indirect way of like a variable speed. But now we are calculating average speed. How do we calculate average speed? We have to first try to calculate a total distance traveled by the total time. In this case, let's not assume that I think you need to calculate x1 x plus x. what we have to do, how do you get x value here, the distance value? We have to understand v1 and t1. These are the two variables, right? Velocity v1 and time t1. If you multiply v1 and t1, speed into time, you will get a distance. And then we have to do the same thing for the second part. The total distance would be v1 t1 plus v2 t2. Total time t1 plus t2. That is how we have to see the average speed. So there are the three important cases that we have to study about average speed. We are getting typically the problems on this case. Let's say if a particle travels distance s1, s2, s3 with a speed of v1, v2, v3 in same direction. So what is given? S1, S2, S3 are the distance are given, and then speed v1, v2, v3 are given. So total distance that we know, right? S1 plus S2 plus S3 total distance. But we don't have a total time. We are given only speeds. In order you to calculate the average speed, what is needed is total distance by total time. That is very important. You have to remember, right? So total distance, because average speed, no, for always you have to remember average speed equal to total distance by total time. So the distance anyway we know s1 plus s2 plus s3. But what we need to know is like a time. We don't have a time, no, because you have a distance, we have a velocity. So in order to calculate a time, we need a t1 plus t2 plus t3, right? That's what is needed. How do you get a t1, t2, t1, t2, t3? T1 you get it like s1 by t1, s1 by v1, right? So s1 plus s2 plus s3 divided by t1 means s1 by t1, s1 by v1, right? v1. Distance s2 by v2 speed, distance s3 by v3. So this is the formula. You have to remember. Let's look at a case 2, average speed. So if the particle travels with a speed v1, v2, v3 during the time interval t1, t2, t3, then what is an average speed? That is what is given. So let's try understand this. Average speed we know speed, right? Speed means, how do you calculate this one? Distance, you're right, yes. Distance by time, right? But to calculate distance, what you have to speed into time. So let's say v1, v2, v3, t1, t2, t3, you should also have like a s1, s2 and s3 distances. So how do you calculate s1? S1 is nothing but v1, t1, s2 means v2, t2, s3 means v3, t3. So total s means s1 plus s2 plus s3. This is nothing but v1, t1, v2, t2 and v3, t3. And time t anyway is given t1 plus t2 plus t3. So average speed is nothing but total distance by total time, right? So v1 t1 plus v2 t2 plus v3 t3 divided by t1 plus t2 plus t3 is what is average speed. This is very important. I think you people try to understand, because we will getting like very simple problems with straight problems too. Let's look at a case 3. If a particle travels with speed v1, v2, v3 during the time interval t1, t2, t3 equal to t, then average speed. It's very simple, right? t1 plus t2 plus t3 is what is already given, which is nothing but your t's. Total time is like 3t. And then total distance, you know the formula v1 t1, v2 t2, v3 t3. If all t's are same, then you can take the common out. So t into v1 plus v2 plus v3. So total distance by total time. Total distance is like what? This one. Total time is like 3t. So how do you calculate? So average speed equal to t into v1 plus v2 plus v3 divided by total time, right? Is 3t. So what you get? v1 plus v2 plus v3 by 3. Is it not easy? So if you given like a speeds and equal interval of time, then the average would be straight through v1 plus v2 plus v3 by 3. If you have 4, v4 by 4. If it's 2, v1 plus v2 by 2. That is how you can calculate average speed. Clear? Move on to next problem. A particle moving in a straight line covers half the distance with a speed 3 meters per second. The other half the distance is covered in two equal time intervals with a speed of 4.5 meter per second, 7.5 meter per second respectively. So the average speed during this motion is what they needed. So who is going to try? Okay, shall we try? Look at actually what is given. All the inputs you can collect. You can start it putting what formula that we need to use to arrive the answer. We studied right previously all the three cases how we can apply average speed calculation. So let me write down. So there is a distance, right? And then half distance. That's what the story is saying. Very good. So this half distance, let's say this is x by 2 and this is also x by 2. This x by 2, what is given? 3 meters per second is given speed. Half of the distance is covered 3 meters per second. So what would be the t1? T1 would be x by 2 by 3. That means x by 6 seconds. This is a t1. Good. Now look at this second half. There is a condition, right? So the distance is covered in two equal time intervals with the speed of this much. So there is a small portion split. This again. Probably this is how I think you look at it. Same times. That's what it's saying, right? If this is a T2, so probably this also T2. T2 and T2 both are same. So how do you calculate this one? You get a 4.5 meters per second this one, 7.5 meters per second this one. Right? Total distance x by 2. Is it? Okay. What you should do now? You can calculate distance. Velocity into time is a distance, right? Agree? So 4.5 T2 plus 7.5 T2 equal to your distance, total distance x by 2. So if you can sum it, how much? 4.5 plus 7.5 is 12. 12 T2 equal to x by 2. So T2 equal to x by 24 is what is given. So we have a T1 and then we have a T2. So what is an average speed now? Average speed formula, friends. Total distance by total time. Total distance is what? X only. X by 2 plus x by 2. It's a x. Total time x by 24. How much we have total time? Let's say time t equal to t1 plus t2 plus t2. So x by 6 plus x by 24 plus x by 24. Is it? Good. So how do you calculate this one? 24. Maybe this is 4. 4x plus x plus x by 24. So 6x by 24. So it's nothing but x by 4. Okay, so this one would be x by 4. So 4 meters per second would be average speed. Alright, good. Let me box it. Good problem. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. We reached the end of session. Thanks for all who are actually joined today's class. I hope this class is useful. Try to spend some time, quality time in your preparation. Okay. Stay tuned to next session. See you tomorrow, guys. Okay. Have a good day.